So every challenge question from the Pearson textbooks, part 3, chapter 3, this is on simultaneous equations, I believe, which is cool. Some year 12s actually know some maths at this point, so the questions might actually start getting a little bit more difficult. But not really, though. One pair of solutions means b squared minus 4ac is equal to 0, of course. I've just rearranged both of these for y, I guess. No, just this one, and then put that in there. Yeah, good. And then expand that out. Remember, that's k plus x times k plus x. Expand it properly. It's not k squared plus x squared, because of course it's not. Anyway, then we put this together to make this. This is the a term, this is the b term, this is the c term. And as I was saying, b squared minus 4ac needs to equal 0. So a is 2, b is 2k, and c is all of this. B squared is 2k all squared, which is 4k squared. If you make that mistake in my classroom, you just get sent out, because of course you do. Anyway, this can group together, or you can just put it over here, divide by 4, and square root, and we end up with plus or minus 2 root 2, which is good. Excellent, done. Question number 2 then, you get these sets here, A is this, B is this, C is this, and you want to be A intersecting with B or C. So in English, you say you have to be A, and you have to be one of B or C. That's kind of what we're saying here. So okay, well, let's just simplify all of these. I started with B, apparently, don't know why. Take away one from both sides, then double it, obviously, so this is the condition for B to be true. Then maybe we do A or C, I'm not sure if we do C, apparently, I don't know for sure. Add 1, then divide by 2, and we get this condition for C. And this one here, take away 5, divide by 3, and we get, take away 5, divide by 3, and we get this condition for A. So we have to have this to be true, and we need either B or C to be true. So let's combine A and B first. If A and B are true together, that means we're between -1 and 4 with the 4 inclusive. And if A and C are true together, well, C is saying you need to be greater than 6, and A is saying you need to be greater than -1, which means you just need to be greater than 6. Because if you're greater than 6, you are greater than -1. So we just have to be this one if we're going to be A and C. And so we end up with this in notation. Like I said, between -1 and 4 with the 4 inclusive, or just bigger than 6. Good. 3f then. So coordinates of the intersection. So we're just going to set this thing equal to this thing. We're going to simplify, obviously, and that factorizes, does it? It does, good. So either x is minus 3 over 2. And of course, we need the coordinates. So that's clearly this x coordinate here for this intersection. But we need to substitute that value into here to find the y coordinate. So this is just me doing that. You can type it into the calculator, obviously. But anyway, you get this. So that coordinate is at minus 3 over 2 minus 15 over 4. And this coordinate, of course, is when x is 6. And if you put x as 6 into here, you can actually see that y is going to be 0. And we get that coordinate as well. So I actually didn't write down the coordinates very thoroughly, which I should have done. They're this, and this. And then, of course, the set notation for when f of x is less than g. Now, g is the red graph because it's the upside-down quadratic. And so all this is saying, really, is you want the red graph to be above the black graph. That's what this means. And the red graph is above the black graph, of course, between minus 3 over 2 and 6 for our x values. And that's where that comes from there. Good. So the last bit is from the mixed exercise then. So possible values where this equation has real roots. Real roots is b squared minus c 4ac is greater or equal to 0, because, of course, one root would classify as real roots because it would just have one repeated root that's real, I guess. So we can do this. A is 2k, B is 5k, and C is 5k minus 3. So it looks like this. 5k squared, I'll say it again, is 25k squared. So that's that. Expand this out, you get this. Those two things go together to make minus 15k squared. And you can factorize this to look like this. Now, the critical values here are clearly when k is 0, and when k is, just solve this bracket for 0, it's when it's, is it 8 over 5? Now, those are critical values. Now, this is an upside-down quadratic. So imagine an upside-down quadratic in your head that has roots essentially at 0 and 8 over 5. To be above 0, you need to be between those two roots because the quadratic is upside down. And so we need to be between 0 and 8 over 5 like this. Except if you actually try and use k as 0 and put k as 0 into here, you end up with minus 3 equals 0, which obviously isn't true. And so we remove the equal to 0 option here, and we leave this as our final answer. I've seen them do that a couple of times, including in an AS exam paper, and it's just, you just need to bear it in mind sometimes. Anyway, straight line has this, and parabola has this. Range for which the line and parabola do not intersect. Now, just be careful about this. Do not intersect. Now, intersection is when two curves do this, right? They go through each other and past each other like this. If you've got two curves that just touch each other and are tangent to each other, that's not intersection. That's just touching. So do not intersect. You need specifically b squared minus 4ac less than or equal to 0. Because if b squared minus 4ac is equal to 0, that's just tangential, that's touching, but that's not intersecting, which is cool because we don't want intersecting. So we're allowed to be 0 here. So that's just a small thing to have there. Anyway, from there it's very easy. You just set this equal to this. You rearrange, you get your a, your b, and your c. And then you put it into b squared minus 4ac to make this. This squares, of course, is 2k minus 2 times 2k minus 2, which you expand out. This turns out to be this. Simplify everything up. Divide by 4, I guess, probably works. Factorize. Of course, the calculator will do it from here, but anyway. Critical value is at 7 and minus 2. This is a quadratic that's the right way up. And critical value is 7 and minus 2. You want to be less than 0, so you want to be in between the roots again this time. Or the critical values, really, I should say. And we'll end up with this as our answer. And yeah, I think that's everything from chapter 3. Thanks for watching. I'll see you for chapter 4.